Picture motion synchronized to the microsecond. Dozens of servo axes moving as one. A CNC interpolating a curve. A robot tracing a path. Ordinary Ethernet simply cannot keep up. EtherCAT can. It is the network that runs the fastest, most tightly coordinated machines in industry. So how does one Ethernet variant hit cycle times the rest cannot touch? In this video, I will explain what EtherCAT actually is. We start from why normal switched Ethernet is too slow for motion. Then the one clever trick that makes EtherCAT so fast, processing on the fly. Why that speed matters for servos and synchronization. And where EtherCAT fits next to PROFINET and Ethernet/IP. Let's start with the frame. Quick note before we dig in. This is from PLC Simulator, where you can practice PLC networking and the rest of this video free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now, back to the network. So what is EtherCAT? EtherCAT stands for Ethernet for Control Automation Technology. It is an industrial Ethernet. It uses standard Ethernet cabling and the standard Ethernet frame. But it is real-time and deterministic, which means it delivers data on a fixed, guaranteed schedule, cycle after cycle, with almost no variation. Here is the contrast that matters. Normal office Ethernet is switched and stored forward. Every switch receives a whole frame, holds it in a buffer, checks it, then sends it on. Add a few hops, and the delay piles up, and worse, it varies. That variation is called jitter. For loading a web page, you never notice. For motion control, where every axis must update on the exact same cycle, that timing slop is fatal. So EtherCAT does something completely different. Here is the trick. EtherCAT throws out the switch entirely. The master sends out one single frame. That frame passes through every slave device in the line, one after another, like a train running down a track. And this is the key part. Each slave does not receive the frame, store it, and forward it. Instead, the bits of the frame stream straight through the slave's hardware. As they pass, the slave reads the few bytes addressed to it and writes its own data into that same frame on the way past. It happens in dedicated hardware, in nanoseconds, while the frame is still moving. They call it processing on the fly. The frame travels to the end of the chain, loops back, and returns to the master. Now it carries fresh data from into every device. So one telegram, one trip, serves the entire network on every cycle. No per-device packets, no store and forward delay at each node. That is why EtherCAT reaches cycle times down in the tens of microseconds across dozens or even hundreds of devices. Now, why does that matter so much? The answer is motion. Think of coordinating many servo axes, a robot arm, a CNC, a flying shear, a high-speed packaging machine. Every axis has to be commanded together, interpolated together, and updated on the same fixed cycle. A slow or jittery network breaks the coordination, and the motion gets rough or unstable. EtherCAT's speed and determinism are exactly what that job needs. And there's a second piece, distributed clocks. EtherCAT synchronizes a clock inside every slave, so they all share the same sense of time, aligned to well under a microsecond. That means outputs across the whole machine can fire at the same instant, not whenever each device happens to get the message. Fast, deterministic input and output rides on the very same bus. So, is EtherCAT just better than everything else? No, it is built for a different job. PROFINET and Ethernet/IP are also industrial Ethernet, and I have separate videos on both, linked below. But they are switch networks. They use standard switches, they play nicely with normal IT infrastructure, and they are excellent for connecting cells, lines, and whole plants together. EtherCAT trades some of that flexibility for raw motion performance. It wins where tight synchronization and the fastest possible cycle are the entire point. Think CNC machines, robotics, packaging, and anything with a high axis count. So it is not one network replacing the others. PROFINET and Ethernet/IP for the plant and the cell. EtherCAT for the motion. Pick the tool for the job. So here's what to walk away with. EtherCAT is a real-time, deterministic industrial Ethernet. Its one big idea is processing on the fly. A single frame streams through every slave, each reading and writing its slice as it passes. So one telegram serves the whole network in microseconds. Distributed clocks keep every device aligned to under a microsecond, which is exactly what synchronized motion needs. And it lives alongside PROFINET and Ethernet/IP, not in place of them. EtherCAT for motion, the switch networks for the plant. Get that, and every fast machine on the floor stops being a mystery. Now, go make it concrete. If you want to practice PLC networking hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.